If you didn't get a chance to visit Lenovo at ISC23, you're still in luck. Check out their Inside HPC booth video to get caught up on the latest from Lenovo and HPC. Visit insidehpc.com/Lenovo-ISC video.
Like many other emerging technologies, I expect quantum computing will find a home within HPC before it does anywhere else. And it behooves quantum computing vendors to pay attention to HPC if they're not already.
Sustainability was everywhere, and it's firmly established as an issue that goes well beyond just being a good corporate citizen and showing that you care about the environment. It's such a huge cost problem.
They're also acting like system vendors. So are we getting to an era where everybody's a system vendor?
From Orion X in association with Inside HPC, this is the @HPC podcast. Join Shaheen Khan and Doug Black as they discuss supercomputing technologies and the applications, markets, and policies that shape them. Thank you for being with us.
Hey Shaheen, great to be with you.
Excellent to be here. How was ISC? You're back.
Yes, I'm back, and it's been a few days since returning from Europe. I spent a few days in France after the conference.
Excellent.
Yeah, I'm feeling as though I'm returning to the living as far as jet lag goes. But ISC, overall, a very good conference. And this show is making a steady return, hopefully to pre-pandemic numbers. They had 3,100 attendees this year. That does not match their pre-pandemic attendance figures, but more than last year. And they had more exhibitors, almost 160. It's interesting to compare this show and last year, because last year was the first ISC in person since 2019. And there was kind of a sense of some degree, I would say, of euphoria. People were just very happy to be back together, seeing old friends, old colleagues, familiar faces, and just to be traveling again after COVID. But the irony was last year's conference turned into something of a super spreader event, not to make light of it.
Yeah.
You know, the COVID issue is done and gone. But the other thing about last year was Frontier had just arrived, certified first exascale system on the top 500 list. That was very exciting. There's a lot of buzz around HPE and AMD booths. People wanted to see the Frontier blade and talk with AMD about their processors. That was a milestone news event. So
for sure.
This year, a little more low-key. There was not a major news piece like that to kind of drive discussion this year. You know, a lot of talk, of course, about generative AI, ChatGPT, and a lot of general discussions on the major issues, for example, around the emergence of quantum and real-world workloads that we're seeing, where quantum techniques combined with classical HPC, it's actually being utilized. The European HPC efforts, increasingly impressive. And Europe is certainly emerging as a major supercomputing center, more increasingly so. They have 2 of the top 500 systems. So overall, interesting, good show.
Yeah, absolutely. I was virtual, as you know, and the online program wasn't as rich as previous years. Things are not live. The streaming sometimes was recorded and available later, and some sessions did not have that digital option. So from that standpoint, the experience was decidedly in favor of being there in person. But still quite a few talks that were available, and of course the coverage was good. Like you, I also noticed a bunch of quantum computing. Like many other emerging technologies, I expect quantum computing will find a home within HPC before it does anywhere else. And it behooves quantum computing vendors to pay attention to HPC if they're not already. As you mentioned, the joint undertaking, the EuroHPC program, with the centers that they have around the continent in France, Germany, Italy, Poland, Spain, Czechia, they're all spending the order of 100 million euros over some years to boost quantum computing presence. And then, of course, Europe as a continent, as you mentioned, is investing heavily in supercomputing and quantum computing, both at the European level as well as individual countries. Germany said something like 3 billion euros investing in quantum computing and aims to be a leading provider. The EU, of course, has a bunch of money put in. UK has a separate program, both for HPC and then another one for quantum computing. So those were kind of visible. And also a bunch of decarbonization, ESG. Our previous episodes talked about decarbonization and liquid cooling And it was good and reconfirmation of that emerging topic.
Yeah, sustainability was everywhere. And it's firmly established as an issue that goes well beyond just being a good corporate citizen and showing that you care about the environment. It's such a huge cost problem that the two combine, the environmental side and the financial side. It's just a huge emerging issue that vendors are talking about very heavily.
That's right. We talked about the top 500 when it first came out.
Mm-hmm.
There were a few things that our analysis was pointing to, but we didn't have time to cover it when we recorded it. So one observation was the emergence of Microsoft and then secondarily NVIDIA as folks who actually have systems on the top 500. I do want to just say how delighted I am with Microsoft actually disclosing information and posting on top 500. You know, I was criticizing them a couple of years ago when they said they've got the equivalent of the number 5, but they were not going to say much about it.
Yeah.
So they came back, and they came back in force. So they had number 11 on the top 500 was a Microsoft Azure AI supercomputer with something like 2,000 AMD GPUs, MI250Xs, obviously quite nice. And that's the highest entry outside of the highest new entry, basically. But then they actually have 7 systems on the top 500 list, Microsoft does. Number 11, number 16, 42, 43, 44, 45, 4 in a row. And then number 289, all the way kind of in the bottom half. But they're running real-world HPC applications. It's not like they just configured it to run HPL and call it good. So good for Microsoft. Thank you. Please do more. And we would love to mention you every time with the kind of applause that you deserve.
Now, these are all housed in Azure. Am I correct?
That is correct. These are all Azure systems that are not sort of a temporary partition, but actual systems set up and intended to run HPC AI, high-end numerically intensive calculations. And Microsoft has a really good technological basis, as do the others, but probably in my estimation, a little bit ahead in some areas like networking and such.
Yep, they're famous for having had InfiniBand for a number of years now.
Right, but they also do some really cool, AWS does too, as Adrian mentioned a few episodes ago, with their flow control and what they do to get more out of Ethernet. But Microsoft also does a lot of work with telco companies on severization of 5G and the networking that they do, and some really advanced work that I remember noting a few months ago when they were talking about it. But the other interesting thing is that there are not many organizations that run more than one system on the top 500. Obviously, Oak Ridge has several systems between Frontier and the testbed and Summit and Sierra, and perhaps historically, DOE Labs have done that. But what was interesting to me is that Microsoft has 7 systems in the top 500, of which 6 are in the top 100. And NVIDIA has 4 systems in the top 100, like not systems that happen to have NVIDIA chips, but systems that are owned and operated by NVIDIA. That kind of really is interesting. And then you put that next to the other observation that these big cloud providers are doing their own chips too. Obviously, AWS is doing Graviton, Google is doing the TPUs as well as other chips. I think they did a video encoding, decoding chip some time ago. Microsoft has some activity, and Facebook, Meta just talked about their 2nd generation AI chip. So these big cloud providers and big players are starting to act like system vendors. So it makes you think, are we living in a world where the cloud guys can roll their own and therefore they act like system vendors, and the chip guys are increasingly miniaturizing everything, and with chiplets and big substrates and wafer scale, they're also acting like system vendors. So are we getting to an era where everybody's a system vendor?
Well, it's interesting you bring up Azure and AWS because Hyperion Research and Intersect 360 Research both recently did. Hyperion last week did their annual breakfast, or they do it at CNSC. And the week before, Addison Snell at Intersect 360 released his findings. They were somewhat different. I think Addison had higher growth figures than Hyperion did. One point of distinction between the two of them was Intersect 360 saying that cloud HPC is going to plateau, whereas Hyperion looks at pretty healthy growth going forward. That was a point of difference between the two.
Interesting.
And to your comments about cloud becoming supercomputing systems in the cloud, from such as with Azure, it could be very interesting to see how that unfolds. And who was right, Addison Snell or Earl Joseph?
Yeah. Yeah.
Yeah.
Well, as you know, like what we do is try to project the future based on the trends that we see. And I think that both Intersect and Hyperion have more of a perspective of what happened this past year and how does that fit with what had happened in the 5 years before. And then they can look at those trend lines. So I think maybe the combination is the way to go. But what we have been saying for the past, let's say, 4 years now, is that maybe even longer than that, and we've talked about it on this podcast, is the emergence of a fourth phase of IT where it is edge to core and really device to data center and everything in between, rather than mobile cloud, which was the phase we were in just before this one. And then before that, it was client server. And before that, it was terminal mainframe. And this fourth phase was going to lead into an enterprise fabric where computing happens everywhere, from the sensor all the way to the supercomputer, from 5G and IoT to exascale, from device to data center, from edge to cloud. No matter how you describe that end-to-end spectrum, it needs to be connected with various types of fabric. But every node on that fabric is going to be AI enabled, analytics enabled, HPC enabled, proportionate to what it needs to do.
To its workloads, yeah.
So I think that if you look at it that way, then it's not that the cloud is peaking. It's not that the cloud is going to stop growing. It's that the cloud has to share the stage with the rest of the spectrum of computing that is available to the enterprise. And those are important and are places for non-trivial revenue for the vendors and non-trivial impact for the customers. You have to look at all of it and get a fuller perspective.
Yeah. There probably is a degree of rapid initial growth that almost necessarily slows down at some point or does not keep its early hot pace. And as you say, within the larger IT ecosystem, it takes its place, a more mature place from a market share perspective.
Yeah. I mean, my point is that cloud is important, will remain important, it will continue to grow, but it won't be the only game in town. You have to expand your vision to go from sensor to supercomputer and everything in between.
Do you have views on why, for example, AWS feels it necessary to build its own chips? What is driving that? Why can't they find what they need from the chip makers themselves?
Well, they do. I mean, the answer is that they do buy a lot of chips from chip makers.
Yeah.
And they buy a lot of motherboards and they buy a lot of full systems and they buy a lot of, right? So if you look at the totality of what they buy a lot. But if they know that they're going to have need for N thousand units of something, and if they design it just so they can extract 1% more profit or cut 1% more cost, well, then they're going to do it. And I think that's what we're observing, is that whatever they build is, well, not whatever. Some of what they build is not to the exclusion of competition, but in addition to.
And to take on a particular role, as you say.
And to take on a particular role. That's right.
Exactly. At the volume and economies of scale we're talking about, then that can make a difference.
And then the other thing is that to do so is more affordable than it was 20 years ago. So the barriers to entry to roll your own and to build your own custom chip are a lot lower than they were 20 years ago.
Really?
Nowadays you design a chip and a lot more likely than not, it works the first time. You don't have to tape out half a dozen times to get it right. The tools are more mature. The designers are more experienced. We've all been around the block a lot more times. The IP, the whole thing is just a lot more mature.
The EDA. Yeah.
Exactly. The EDA, the IP, the physical layer, the fabrication layer, what TSMC and Intel Foundries and others provide, those are all a lot better understood, and people can now do it with a lot less cost than before.
Didn't get a chance to visit the Lenovo booth at ISC23, or you simply just want to see it again? Check out their Inside HPC booth video, where Lenovo discusses sustainability, Neptune liquid cooling technologies, and the latest in HPC solutions. Visit insidehpc.com/Lenovo-ISC video to view the video.
Okay, so one thing that created quite a stir, a lot of conversation, was an opening keynote from Dan Reed, presidential professor at the University of Utah and chair of the U.S. National Science Board, which provides oversight for the NSF. But he's obviously a major strategic figure in leadership computing at the national labs. He presented a mixed picture of, especially at the leadership level, leadership class level, of kind of a dire business environment for building the next generation of systems. He said that our current model for configuring, procuring, and constructing leading edge HPC is predicated on an older model of vibrant commercial computing market whose interests and products align with scientific computing needs, but that is decreasingly the case. He says the scientific computing world now lacks the financial leverage to dictate HPC product specifications at the very high end. The leading edge HPC market is too small. And it was very interesting. It's sort of in the post-exascale era. How do we build these next generation systems?
Dan was also a distinguished guest of this podcast that boasts quite a few distinguished guests, if I may say so myself. And we've had the delightful experience of having the perspectives from folks like Dan Reed and Jack D'Angaro and Horst Simon and several others who have delighted us with being here. So there's a lot that I hear, both in what Dan mentioned and the paper that he wrote with Jack D'Angaro and Dennis Gannon about a year ago this time, and the associated blogs that were a motivation to have the podcast that we did before. And I read some of the National Science Board's reports on what's being recommended. So really, all of that really sounds quite good, and the analysis is just right, and the mega trends are unmistakable. It's very true that these mega hyperscale providers are dealing with very astronomical numbers, and they're not going to be swayed by the supercomputing budget of a typical user, let's say. But it is also true, and this is really the part that I want to add, it is also true that HPC is in fact where the money is. So I expect that those organizations will pursue HPC, albeit perhaps in their own way and not in a way that the leading edge site needs to be or at the pace that the HPC community wants to be. So from that standpoint, I agree. But in general, I think that companies and organizations that pursue HPC are on the right side of history.
Well, certainly, I think I completely agree with you there. But I think what your comments really apply to, the somewhat broader HPC market, say below the top 100 kind of systems. And I think what he's talking about are, for example, the observation we heard last week that the top 8 systems on the top 500 list have an aggregate throughput that matches the remaining 492. So if we're talking about the top 10 systems, it's a difficult business proposition for vendors to go after that top 10 market. These systems, as Reed said, the procurements are too infrequent, the funding is too small, and the financial risk to vendors is too high. It'll be very interesting to see how post-exascale unfolds. We talked a lot about the DOE RFI from last June, which was kind of outlined their strategic thinking for next generation systems. They want to move away from this monolithic idea toward more modular, less monolithic approach within the IRI, the Integrated Research Infrastructure. So,
right.
And sort of a big part of that aim, and I think Dan and Jack D'Angaro confirmed this, is they're trying to draw more vendors into the building of those systems. So, Again, very interesting to see how this unfolds.
I think a crux of this discussion is whether or not AI qualifies under the umbrella of HPC, not just kind of adjacent to it. And of course, as you know, I have been waving the flag of AI being just another HPC workload and contributing to HPC over time by being used by HPC as well as using HPC and impacting the technologies that HPC will then take advantage of. And I think that may just be where some of the analysis should be. But to me, if you say follow the money, which is sort of how his talk got summarized in some of the articles, I think HPC is the money. I think pushing for increased performance obviously cannot be taken for granted. Doing at the high end may or may not really be what vendors are doing, and you need instruments to influence that. But if you look at HPC as the entire spectrum, like we were talking about, if scientific instruments like an X-ray crystallography machine or a particle accelerator or some chemical, separation instrument, if those are also going to be supercomputers, then that is entirely new co-design territory, and it's also a place for complexity albeit it's not so driven by cloud and more by kind of device manufacturers. But HPC really, I don't see it as a niche market that may or may not get attention. I think it will get attention. It may just not be the kind of attention that I need for my roadmap for something that I need 2 years from now. That part I agree with. The other part, really the bigger part, is that the economy of the future is digital. Making sense of data is HPC. You could say that it's AI, not HPC, but AI hardware looks like HPC hardware. AI algorithms look like HPC algorithms. Over time, they will look even more like HPC algorithms. And AI skill set looks like HPC skill set. So it kind of walks and talks like a duck, and maybe it is a duck. So I think it is HPC. And I think that's what astute tech vendors already see, and they already thrive because of it. So I think HPC is the only part of IT that will grow faster than GDP, faster than population, faster even than connected devices. So I therefore conclude HPC is the future, not just the money. But everybody knows that that's what I think. And I'm going to keep saying it.
Well, I said many times last week talking to people, HPC and AI are like two planets sharing an orbit. They feed off of each other. They're really so increasingly converging and driving each other. So, yeah, I'm in violent agreement with you, Shaheen.
Yeah, really, the only part of AI that sort of became a little bit of a difference is mixed precision. Is that, hey, maybe I don't need 64 bits. In fact, maybe I don't even need 32 bits. Maybe I don't even need 16 bits. And as you sort of go down and you gain speed as a result of that, guess what happens? People who are speed junkies like HPC are going to want to see if they can use it. And they're finding ways to use it. So that is really the part where HPC is going to take advantage of the hardware changes that AI is causing to the benefit of both of them. But I think the two major things are, A, we live in post-Moore's law world. So speed comes not from higher frequencies, but from using your transistor budget, your increasing transistor budget to have architectural improvements. And then B, you're no longer inside the walls of the data center. You are physically decentralized from sensor to supercomputer. And that means that the supercomputer you're building isn't just the cluster that used to sit in the data center, but the whole fabric that extends all the way to instrumentation and the integrated research infrastructure. That is another vision that captures that.
Yeah, and on the mixed precision front, we heard Jensen made some pretty prominent and highly covered, Jensen Huang, CEO of NVIDIA, in which I believe he said GPUs are taking over and it won't be long, or at some point, GPUs will be handling 95% of computing. And it'll all be faster and faster.
Yeah. Well, let me rephrase that. I think I think all applications will be AI enabled. Most all of them will be AI enabled. Now, exactly what hardware platform runs that AI workload is going to depend. Sometimes you can use the vector instructions on a CPU. And in fact, the farther away you get from the data center, the more appealing that becomes. Even inside the data center, that continues to be a path. You're going to see accelerations coming from analog and digital devices. You'll see quantum computing accelerating some of it. And yes, GPUs will be a major part of it because they have the momentum right now. But not all problems can be formulated to take advantage of GPUs.
But Jensen is a great showman and spokesperson and marketer.
Jensen is also just a great CEO. He has been one of the best CEOs in the Valley for decades. I've been saying it for about as long. But then you also look at Lisa Su, you also look at Pat Gelsinger, you also look at several others, and we are really lucky to have a cadre of technology leaders who are just so good. And they're all dealing with their own realities and they have different problems to solve. But I'm really delighted to just watch them in action and see how they do it. One other topic I wanted to bring up is really the importance of open systems and open source. And as we see this new era of computing get gelled, I think you're going to see open systems and open source software and even open hardware to come back up. We've seen examples of that with RISC-V at the chip level, all the way to Linux in the middle, all the way up to some of the AI frameworks that are now open source and fueling things. I expect that to remain an important topic and actually become more important in the coming years.
Yeah, that would be really fun to put some focus on that. And, it's a perennial source of conflict open versus non. But as you say, yeah, increasingly important. So that's something we can really look forward to.
Yeah, I would like us to come back to it maybe in future episodes.
Very good. All right, Shaheen. Well, thanks so much. As always, great to be with you.
Excellent. Welcome back. Thank you, everybody, for listening. Until next time, take care.
That's it for this episode of the @HPC podcast. Every episode is featured on InsideHPC.com and posted on OrionX.net. Use the comment section or tweet us with any questions or to propose topics of discussion. If you like the show, rate and review it on Apple Podcasts or wherever you listen. The @HPC podcast is a production of OrionX in association with Inside HPC. Thank you for listening.